Hello everyone, my name is Charan and along with my teammates, we are pleased to present our internship project Real-Time EV Dashboard and ADAS System using STM32 and Python. The main aim of our project is to develop a real-time electrical vehicle dashboard that continuously monitors important vehicle parameters while also providing advanced driver assistance system or ADAS safety features. Our project integrates embedded system, serial communication, and software visualization. We have used STM32 as a controller, PixSimLab for simulating vehicle sensor, UART for communication, and a Python-based GUI for real-time monitoring and displaying safety alerts. And here comes to introduction. Today's electrical vehicles are becoming more popular. Modern EVs needs to monitor the vehicle continuously and also helps the driver stay safe. Most normal dashboards only shows basic information like speed and battery level. They do not give complete vehicle information or at least safety warnings. To solve this problem, we built a real-time EV dashboard with ADAS features. In our project, battery level, speed, motor temperature, tolerant position, current, and RPMs are created using PixSimLab. These values are read and processed by the STM microcontroller. Then the data is sent through UART to the Python dashboard where all the values are shown in real time. The dashboard also gives safety alerts like war speed warning, forward collision warning, blind spot detection, and fault detection. This project shows how embedded system and software can work together to improve vehicle monitoring and device safety. And here comes to the problem statement. Before starting this project, we found some problems with normal vehicle dashboards. First, they do not show all vehicle information in one place. Second, problems like temperature, high speed, or battery issue may not be detected early. The third, most dashboards do not have safety features like collision warning or blind spot detection. Also important TV information like battery level, motor temperature, and trolley position is not shown in a simple and clear way. So we developed this project to monitor vehicle data in real time and give safety alerts to the driver. And here comes to project objective. Based on the problems we identified, we defined the following objectives for our project. Our first objective was to develop a real-time EV dashboard capable of continuously monitoring information vehicle parameters. Secondly, we aimed to simulate electrical vehicle sensor using PixSimLab to create a realistic testing environment without requiring physical hardware. Our next objective was to establish reliable UART communication between STM32 and the Python application for real-time data transmission. We also focused on developing an interactive Python GUI to display vehicle information in an easy to understand format. Finally, one of our major objectives was to implement ADAS safety features such as over speed warning, forward collision warning, blind spot detection, and fault detection to improve driver awareness and overall vehicle safety. With this objective completed, I will now hand over the presentation to my teammate who will explain the tools and technologies used in our project, followed by the overall system architecture.
Hi guys, this is Elchara Venkatapranith from Puttur, and we are going to do I'm going to show you a demo of the electric vehicles and ADAS alert system. And in this, we are going to use the STM32, PixSim, VSPE, and Python softwares. And here we are going to use a processor called STM32F103C8, and it is also called as a blue pin. And we have configured all the pins like a GPIO, ADC, RCC, GPIO pins, and etc. After that, when we have saved it, the IDE has generated a empty code. After that, when we have integrated with the some of the codes, like customized codes, like giving it even configuring the pings, and when we have built the code, it will when we click the hammer icon, then it converts into the binary code. The binary file need to be sent it to the pixim lab. In the pixim lab, there is a, sorry, just a second. Yeah, in the pixim lab we need to select a blue pill board, because it is the same board that we have selected there. And when we load the code, see here we are loading the code. See, there is a file called ev-dashboard.bin, and we have loaded it. The board has been completely loaded with the software. And now see, the first PA0 is the accelerator, PA1 is a brake, and PA2 is SOC, and PA3 is the battery percentage temperature. And we are using the three ultrasonic sensors. The sensor, one is for the straight view, another one is for left, and another one is for right view. And we are using the LED indicators to it indicates the light when the, yeah, it shows the current option, I mean, like something like that. Okay. And the Python dashboard, for the Python dashboard we need to do coding in the Python, and I have done already, so I'm just opening the file. Just a second. Yeah, this is the Python code for the dashboard, and now I am going to run it. When I start running it, a dashboard appears. Just a second. Yeah, before the dashboard runs, we need to connect the both Python dashboard and the pixim lab. To connect these two, we are using a virtual serial port terminal software, and we are selecting a virtual pair because we are connecting only the two things, right? Here com1 is for pixim lab and com2 is for Python dashboard. And when we click next and start running, the pixim lab and Python dashboard automatically syncs with that. Just a second, as you can see here. Yeah, and the communication has been running down, sorry, comms has been connected, and now we are going to run it. Yeah, sorry. See here, when we have given the acceleration in the full, the graph has been drastically gone up, and it is showing the collision warning on the battery percentage, and time, and we are even mentioning the TTC here also, and the TTC is a time to collision. I'm repeating it again. Time to collision. It shows in how many seconds the vehicle is going to collide with another vehicle. See, when I pull the lever down, the fourth one. See there. See, the temperature is absolute zero, and now I am degrading, downing the accelerator. Then the see here, completely the acceleration comes to zero, and I have done the brake too. See, when I have pulled the lever to down, then yeah, this is our project, guys. Thank.
Now I'll explain the implementation behind our project STM32 firmware. The STM32 microcontroller acts as the brain of our system. It continuously reads the sensor values generated in PiximLab using peripherals such as GPIO and ADC. After reading the data, the firmware processes important EV parameters like battery percentage, speed, RPM, and current consumption. It also executes the ADAS logic to detect conditions such as overspeed and collision risk. Finally, all the processed data is transmitted to the Python dashboard through UART communication, and this process repeats continuously in real time. EV parameters. Our dashboard continuously monitors several important EV parameters. These include battery voltage and state of charge, which indicate the battery condition. We also monitor vehicle speed and motor RPM to evaluate vehicle performance. Additionally, motor temperature, throttle position, and current consumption are displayed to help monitor the overall health and efficiency of the vehicle. These parameters are updated continuously and displayed in real time. ADAS features. Along with vehicle monitoring, we implemented several basic ADAS safety features. The overspeed warning alerts the driver whenever the vehicle exceeds the predefined speed limit. The forward collision warning detects obstacles ahead and provides an alert to avoid accidents. The blind spot detection feature identifies vehicles or obstacles in adjacent lanes that may not be visible to the driver. We also implemented obstacle detection, fall detection, and time to collision when estimate collision risk and improve driver awareness. These features enhance both vehicle safety and the driver experience. Python dashboard. The Python dashboard provides a user-friendly interface for monitoring all vehicle information. It receives real-time data from STM32 through UART and displays parameters such as battery level, speed, RPM, current, temperature, and throttle position. Whenever an unsafe condition is detected, the dashboard immediately displays the corresponding ADAS warning, allowing the driver to take quick action. Project workflow. This slide summarizes the complete workflow of our project. The system starts by initializing the STM32 hardware. Sensors values are then generated using PiximLab and read by the STM32 firmware. The firmware processes the EV parameters, executes the ADAS logic, and sends the processed data through UART. Finally, the Python dashboard receives the data and updates the display continuously. This cycle repeats in real time, ensuring continuous monitoring and instant safety alerts. Finally, my teammate will conclude the presentation by discussing the project outcomes, challenges, and future improvements. Thank you.
This is Nahishi Nandita, and I'm an intern. And now um, I'm going to continue the brief project about the project. And now we are going to discuss about the demo, like demonstration of the project, what we have learned in it. So earlier we have demonstrated our project live, like what was happened in it and what are the things we have done in it. And so you have seen the complete system, how the dashboard works. And so in this, we have successfully started and ended our project. And the so in this, the project is about the EV dashboard. No? In this, we have used some sensors, sensors, and we also used STM32, where we have been generating our code. And in a Pixim lab, we are observing the output. Like output means that how it works in a real time. It is a base structure of the real time process. And the demonstration, um, this demonstration is very successful integration of embedded. So, and we also we have created a dashboard with all updated vehicle parameters, and it also been used in a real time education. Like, and we have been displayed ADAS warning systems, and also in part of it we have discussed about the collision where an unpredictable or any other circumstances will occur. We have been resetting it during the collision. And next, we are going to discuss about the challenges that we have faced in it. So we we are facing a very few, not a few, many of the challenges we are facing where while we are creating any other project, or while we are running our code, while we are simulating our code. And so the challenges will be a part of two types. While technical issues will be there, and while the processing like development issues will be there. So in technical issues we have faced several challenges. Like we are while we are configuring the peripherals of STM32, the peripherals are like GPIO, UDC, and timers and PWMs. So we have been configured this by using a Hall libraries, as you have known. um, and we have faced another challenge is was while establishing UART. So the UART have been established between the STM32 and the Python applications. So we have faced synchronization issues. So we worked on it and we have learned, we have fallen down, and we have again came up with the successful dashboard, smooth and successful dashboard. In addition, we also have been implemented some ADAS features, so which have used in a future times. The ADAS features such as overspeed warning and some collision warnings like blind spot, and the detection is very useful while driving a car or any other things. So kept in and we have kept many alerts in it. So while debugging these, like while we have coming up with these issues, we have improved our implementation by step, and we also checked what is the better way to implement in a very good manner. And next, we are going to discuss about what are the outcomes that we have gone through the whole internship process. And internship is not only the internship, like while the project making process, we have so much outcome we have dragged from the internship. Like we have experienced a practical, and we are very nil while using the STM32, or we doesn't know about the Pixim lab up to here. So, and we have known about it very clearly, and we are ready to implement it while we are doing in our colleges, like etc. So in this, we improved our embedded C programming skills and also gained some project experience where we configured how to uh, how to learn and how to configure the peripherals, STM32 peripherals. And we also have gone through a software side, and we developed our Python skills, how to write a code by using Hall, and how to write a code in a Python to execute in a STM32. And we are so glad, and we also gained some better understanding of how the electrical vehicle will be will be working, and how the architecture of the electrical vehicle will be there, and how the embedded hardware will works in it, how it will be processed, or how it will be worked while driving. We have seen about it. And so this project has been given more problem solving skills. And next we are going to look into a future hope where our project current is developed our project is current about EV dashboard, where electrical the coming up generation will be a more of electrical vehicles, like because it is a pollution free vehicles. And the system can be integrated with the actual electronic vehicle sensors and hardware. So we have been added additional features like canvas communication, and we canvas communication, and how the tracking will be happen, like while tracking our routes, or while reaching one place to another place. And the voice alerts has been increased, and how how it will be monitored. So the future will be more of hardware and etc. So either it may be AML will be more, but the I think so the hardware part will be more. So this will help us to improve our skills as an ECE department student. And next, these are the outcomes we have learned, and it is a great opportunity to have a internship program with the company. And Thank you for the thank you for the sirs or lectures or that you have given me will improve our knowledge and it will help in our future. So thank you everyone and thanks to my teammates who have helped me to do this project.